So large-scale refactoring with Codemods. As I said, my name's Ed Yarborough, and I work at BBC for iPlayer. We're hiring. If you want to work at scale, come and talk to me. And also part of the Vue core team. So yeah, this talk is about refactoring and refactoring effectively. Because as JavaScript developers, we're working with a language that moves very quickly. So often we find that apps that we wrote 3 or 4 years ago start to look very outdated, and they use maybe old hacks or old syntax that could be updated to improve the speed of our apps and to improve the readability of our code. So I saw this meme the other day on Twitter, and I found it quite funny. But it's kind of true. Like, if you look at code from 5 years ago, it looks like a horrible pile of hacks. And that's just because the language is evolving. So if you want to make sure that your code base is up to date and modern, then you need to find a way to perform refactors and to change that code efficiently without spending too much of your development time doing it. So to talk about how you can use Codemods to do that, I'm going to use an example of replacing a flatten utility method. So flatten is a method in Lodash that takes a nested array and flattens it by 1 depth into an array. So this is a really common utility, and TC39 decided to add it to the standards. So they're adding a flatten method to the array prototype. Unfortunately, there were some issues with the flatten method, and it broke a website. So now it's called flat, but that's fine. So in this talk, I'm going to show you how we would refactor an app that uses flatten to use the flat array prototype method instead. And the way we would do this is remove all imports of flatten from the app and convert all the calls of flatten into an array flat prototype method call. So if you've decided to do this refactoring, the first approach you might take is to do it all manually. And that works fine on a small app, but you might do a find and replace and discover that you have thousands of instances of using flatten in your application. And doing it manually, it's going to take a long time. It's hard to justify. It's just not going to work. So you do some Googling, and you find this library called Codemod. And so as far as I can tell, this is actually where the term Codemods comes from. Codemod is an old Facebook library from about 10 years ago. And the way that it works is you pass it in a regex for it to match. And for the second argument, you give it a replacement regex. It's a bit like a fancy find and replace. And you can run this on a project, and it will go through, find every instance, and prompt you on whether you want to replace the matching instance with your replacement regex. And this works fine until you discover that people have been using flatten in strange ways, and you're not actually as good at regex as you originally thought. And then also you still have these import statements. So even if you do that, you're going to have to go through and manually remove these import statements. And yeah, you could write some regex to do this, but it would be very difficult. I wouldn't want to attempt that. So regex doesn't work either. And so you do some more Googling, and you'll find this library called JSCodeshift. So JSCodeshift is a CLI tool, and the way it works is that you use it to modify JavaScript by editing the AST. So if you're like me, you would probably Google what AST is and discover that AST stands for Abstract Syntax Tree. And if you read the Wikipedia page, you'll see that an abstract syntax tree is a tree representation of the syntactic structure of source code. And if you're also like me, that probably won't make much sense to you. So I'll show you an example of an AST using some JavaScript source code. Up in the left, we have some source code. It's a sum function that takes some parameters and returns the sum of its parameters. I've just realized that's invalid JavaScript. And then we have a call to sum. And the representation of this as an abstract syntax tree is that you have a root program node that represents the entire script or module. And then you have a function declaration node. That function declaration node contains a block statement node, which is the code inside the curly braces. And inside the block statement, you have a return statement. And then the next node in the tree is an expression statement where you're actually calling sum. And so this is a tree, and in JavaScript you can represent trees using an object. So here we have the same tree, but in an object rather than a diagram. So you see we have our type program. So the program is the root node, and that has a body property, which is an array of child nodes. Then you have a function declaration node, and inside the function declaration body is the block statement. And so you can represent that diagram with this JavaScript code. And the point of AST is that it describes source code effectively. Obviously, this example doesn't have all the information that we need to rebuild source code. So this is a stripped down version, and I'll show you what the function declaration node looks like in more detail. So if you take a closer look at the function declaration node, we have properties like ID, which itself is an AST node. So that's an identifier with the name of sum. And then there's a params array, which is an array of AST nodes. So there's an identifier with the name of A. And we have some Boolean values like async set to false and generator set to false. And then the actual body array, which will contain more nodes like the block statement node. So you can see that we're starting to get the information that we need to describe the original source code. And you can imagine that if we had a way of modifying this and then converting it back into source code, we could safely make changes to code, to our source code. So by changing the params name to arg1 and setting async to true, and then converting this back into source code somehow, we would get a new async function with a different param name. And there's a spec for this, ESTree spec. So ASTs are everywhere in JavaScript. Babel uses them to transpile your code. Prettier uses them to format your code. TypeScript uses ASTs in the compiler. ESLint uses ASTs to perform static analysis on your code. And even Vue uses ASTs as part of the compilation process to generate render functions from template strings. So ASTs are super useful, and they're the core part of how JSCodeshift works. So the way that JSCodeshift works, it's a CLI tool. I think there's a JavaScript API as well, but the way that I work with is you run it, and it will find all of the files matching a glob pattern that you give it, and it will parse each of those files. It will find the file, parse that file into AST, and then perform a transform to generate new AST before printing it back into source code and effectively making and changing the source code in place. So the key part of JSCodeshift is this transform. That's the code that you can write yourself that will modify the AST before it's transformed back into source code. And so the transform itself is pretty simple. JSCodeshift has really nice syntax, a really nice API for performing these transforms. So, for example, to find to replace all of our calls of flatten, we would first find all of the AST nodes that were a call expression that have a callee with the name of flatten. So that's all of the calls to flatten. And then for each of those nodes, run an update function. So the update function takes a path, which is like a wrapper of an AST node. And then here we're going to get the array. So the array is the first argument of the call expression. And then we'll call this replace function to replace the node with a new node that we build. And you can build nodes in JSCodeshift using these builder functions. So here you see we're making a new call expression, which includes a member expression with the array, and then we have the method name, which is flat. So by running this transform, we would find all of the cases where we were calling flatten and then convert it into an array or a method call of the array that flatten was called with. So I will show you what the process of writing these transforms looks like. Oops. So if you do any work with ASTs, AST Explorer is a vital tool. So AST Explorer just gives you a way of seeing what effect your transform has on some code. So in the top left segment, we have the source code that you want to perform a transform on. And then to the right, we have the AST representation. So you can have it in tree mode, which is handy because you can click on a node in a part of the source code and it will take you to the relevant AST node. And you can also see it in JSON, which is less useful. But yeah, you can see the amount of information that we have to describe this source code. And then down here, we have the actual transform. So there's loads of different transforms that you can run in AST Explorer. You can write Babel transforms or eslint transforms. We're going to write a JSCodeshift transform. And then finally, you have the result of the transform. And up here, you can see just how many other languages are supported. So ASTs are everywhere. It's not just a JavaScript phenomenon. So you can use AST Explorer to write a CSS transform, maybe with post-CSS. And there's tons of different parsers as well. So Babylon's the Babel parser, which we'll be using. But there's like a TypeScript parser, a Flow parser, tons of parsers. So what I want to show you is how we would find all of the instances of flatten, all of the imports of flatten, and remove them from the source code. So down here I have my find call, where I'm going to find all of the import declarations. And I'm going to use this filter object to only match import declarations with the source value of Lodash. So you can see that an import declaration has a source node, and the value is Lodash or whatever you're importing. So I want to remove any instances of flatten, any imports of flatten. So the way that it generally goes when you're developing with ASTs is you have to find out the name of the node first. So here, this is an identifier, but it's inside an import specifier, which is on the import declaration. So the import declaration has an array of specifiers. So I'm going to create some new specifiers by filtering the current specifiers. And so a specifier has an imported property with a name. So I'm going to filter and get all specifiers that don't have a name of flatten. And then I can update the specifiers. Whoops. With my filter specifiers and remove that import. So that's really cool. Obviously, I've got this import Lodash. I don't want that. So I could just add some extra code to check that specifies has a length greater than 0. And then if it doesn't, then I just want to remove the node from the tree. So path.prune. Cool. So that's how easy it is to write a transform to do something that's pretty complex. Like it's quite difficult. There's lots of different things that you need to consider if you're trying to write this with a regex. But if you're editing the AST directly, the parser does all of the hard work. It converts it into this AST, and you can just do the relatively easy work of changing some values in it. So you can perform these refactors safely. So if you decide to write a transform, JSCodeshift has awesome testing utils. So testing is always difficult, but with JSCodeshift it's kind of a solved problem. They export this test utils library, and you simply define a test, pass it in the current directory name and the name of your transform, and then you just write a input file that has all of the source code that you want to input into your transform, and then create an output file that has the desired output of your transform. And then when you run the test, your JSCodeshift is going to perform a transform on your input and then compare it against this output and error if it doesn't match. So yeah, JSCodeshift is a great tool to write Codemods by editing the AST. And there's loads of uses for it. So internal refactoring is a lot quicker and safer. If you have large code bases and you've written a transform, it's really quick to just run it and update all your code and do a quick refactor on a large code base. Another use of them is to improve migration path. So the way I actually discovered transforms is when I moved my tests from Mocha over to Jest. And Jest has a load of Codemods that are designed specifically to transform code written, like your tests written with Mocha or another testing framework, into Jest. And that meant that I could move all of my tests over from using Mocha to Jest in a couple of hours, which was amazing. And the other thing about writing transforms is you learn ASTs, which is a really cool power. Because once you know how to write, once you understand ASTs and you know how to use AST Explorer to write your transforms, you can really quickly write ESLint plugins, custom ESLint plugins, or custom Babel plugins. So you could have rules, ESLint rules that are specific to your code base just by writing a quick transform using AST Explorer. So yeah, thanks guys. That's about all I had to say about JSCodeshift. And hopefully that's inspired some of you to go and give it a try. I've added some resources here, so I think we'll get the slides sent round, maybe on the meetup group. And yeah, go and do some refactoring with JSCodeshift.